Alan Haungs, Professor Alan Haungs, Physics 124, SUNY Fredonia. We're going to talk about electromagnetic induction. Um, this is for the lab. In this concept number one here, concept one, we're going to discuss, first of all, what is an electromagnet, because you might not be familiar with that term. So let's start with something very basic here. Uh, Somebody a long time ago made an interesting discovery. They found out that if you took a piece of wire and passed current through it, that there would be a magnetic field around the wire. And that's what I'm doing here. So the wire itself is not magnetic at all. But the fact that there's electrical current flowing through it, the current itself actually generates that magnet. Even if the wire wasn't there, if you had a beam of electrons, it would do the same thing. So moving current creates a magnetic field. There's this thing called the right-hand rule. It's based on the convention that current goes from positive to negative. Now, we know that's a wrong assumption, but that started out years ago, so we're sticking with it. If you take your hand, you say your thumb goes this way, the current goes this way, the electric field is wrapping around it like this, so that means that north is going this way, and so the south of this compass is attracted to that. Okay, so that's something somebody noticed. Then somebody had a really interesting idea. They said, what if we took that wire? What if we took that wire and just wrapped it into a coil? What would happen? Right? So here's a coil. It's got about 108 turns. 108 turns of wire. And what it does is it essentially amplifies the effect of what I just showed you. So I was passing 3 amps of current through that single piece of wire. This is 108. So so you could say there's approximately this 300 amps of current flowing through this little square area here, because I have 3 amps flowing through each wire, and there's about 100 turns. So what you get is a tremendous more magnetism when you do that. Based on the right-hand rule, my conventional current is flowing this way in this coil. And so, therefore, if I do the right-hand rule, I go like this. This is north. And sure enough, see, the south part attracts to it. So, now, this is called an electromagnet. When you take coil, you coil of wire and you pass current through it, it's called an electromagnet, because it's not a permanent magnet. There's nothing magnetic about this material. The only thing that's happening is there's current flowing through it. So some smart guy named William Sturgeon, I guess you might say, he invented this idea. Then he discovered that if you took something like this, something that's made of iron or steel, and if you were to wrap this around that, so you got a brick of that steel in here like this, he discovered that the magnet was like super powerful. So steel, irons, various other compounds conduct magnetic field any from thousands to tens of thousands to even over 100,000 times better than air. So you can imagine how it is that if you have a junkyard and you're going to lift up a car with a crane, and you're going to then drop it into a compressor, they just have an electromagnet like this on the end of the head of the crane. It just picks up the car like a toy. So they turn on the electricity in the magnet, car gets attracted, they turn off the electricity, the car drops into the compressor. Okay, so that's a practical electromagnet. This is the coil inside of a speaker. So a speaker would be moving up and down like this. You'd have a permanent magnet field inside here. and by applying current to this coil, you'll get the speaker to move back and forth. This is the armature of a DC motor. Get better lighting on that. There we go. There we go. Those are little electromagnets there. Make sure I get a good focus. Let's see if I can get a good focus on it. Okay. Those are little electromagnets. And as this thing spins, electrical brushes are touching this part right here. And it's turning on and off, or reversing it's reversing the actual electrical flow inside these coils. And so the magnetic field that's inside the inside of this motor, see there's little magnets, permanent magnets, that goes inside of there. See, I took apart a DC motor. These are the brushes that, these are called commutators. Those are called commutators. These are called brushes. This is what supplies the electrical energy to the armature. See, it all goes together. See, and that turns. So that's a practical electromagnet. Another example would be a relay. A relay is when you take a little electromagnet and you open and close this has several switches. So I'll watch it, see what happens. So here's an example of practical electromagnet. So there's a coil in here and some iron material in the center of it. And you can see it pull the switch closed. See the switch close? Let's see if I get a good focus. See it move? So this little device, you could control a very large amount of power by supplying a very teeny amount of power into this coil. And this would then simultaneously make or break 4 different switches on this particular relay. That's a control relay. So that's an electromagnet. So it's not a permanent magnet, not made of permanent magnet materials. It only becomes electrified when charge moves through it. And I gave you the right-hand rule. So I'll follow this up with some more videos and some more explanation.